The information in this CD is stored in a closely wound spiral, but how close is that spiral? The concentric rings are close enough that light is diffracting, so if we treat this like a diffraction grating, we should be able to find the line density with a laser. This laser is shown directly downward onto the surface. If I turn off the lights, so you see on the upper left is the laser, below it is where it hits the CD, and below that is the reflection of it. If I put this piece of paper, here's the laser shining onto the paper. Move the paper to the side. The dot on the paper is the first order diffraction. If I lift the paper to the height of the laser, then that gives a little nice triangle that we can measure. Really better setup. The laser shines through this glass off the CD, reflects back upward, and directly hits the laser again. I can see that by looking at it hitting the glass. And also it refracts to the glass over here. I guarantee that the laser is perfectly vertical because its light shines down and reflects back upward, and the beam passes through the same point in the glass going up and down. And I can ensure that the glass is perfectly level because the light that passes through, goes up and reflects back down, also overlaps the point where it hits the CD. With the laser shining directly down through a normal glass plane onto a normal CD surface, then I can measure where the beam returns on the glass. If I look from this orientation, we can clearly see the laser grows brighter in this position. The beam returns right here. So I have to measure that on the glass, turn the light off, and then just mark. I also mark where the beam passes through the glass initially. Measure the height of the glass. So the glass is 61 millimeters off the ground, and the beam at that point is about 25 millimeters away from the zero order diffraction. The first order diffraction is 25 millimeters away from the zero order diffraction at 61 millimeters up. Those two measurements and this law from Wikipedia, sine theta equals m lambda over d. Sine theta equals m lambda over d. That's good enough. So the laser was shining downward through the glass onto the CD. It reflected upward and diffracted to the side. This is theta. This was measured to be 25 millimeters. The height was measured to be 61 millimeters. So theta equals arctan of 25 over 61. Then let's solve for d up here, because that is the distance between one slit and the next, which is how close the lines are on this CD. So d equals m L over sine theta. We're looking at, this is the 0th order diffraction, reflection. This is the first order. So m equals 1. We're using a red laser, so lambda equals 650 nanometers. And sine of theta equals this number right here, about 22.3 degrees. I'm plugging all of this in. D equals 650 times 10 to the negative 9 over sine of 22.3 degrees, which equals about 1.7 times 10 to the negative 6, so 1.7 micrometers. So that's the answer. Each of these spirals is about 1.7 micrometers away from the next one. That number is bigger than visible light, so it should be visible through a microscope. There they are.